Hi, my name is Jude Hiltner. I chose Grand Teton National Park because I enjoy the lakes and the beauty of the mountains in this park. In the first part of this presentation, I will be discussing the challenges of smog in the park. Later on, I will be talking about the geology of the park. Here is an image from Google Earth. It shows that the park is located in the northwest corner of Wyoming, which is located in the western part of the United States. Grand Teton National Park is located just south of the very well-known Yellowstone National Park. In between the two parks is the John D. Rockefeller Memorial Parkway. This is a 27-mile-long road with a reserved tree forest area around it. As you can see, there's a large lake through the park. On the west side, there are mountains in the park, and on the east side is a camping area as well as the white lines represent roads. This is where the visitors stay. So how is smog an issue in Grand Teton National Park? Well, to start, what is smog? Officially, it is known as a fog or haze combined with smoke and other atmospheric pollutants. However, there is more science to it than that. Today, most of the smog we see is a photochemical smog. Photochemical smog is produced when sunlight reacts with nitrogen oxides and at least one volatile organic compound, or VOC, in the atmosphere. Nitrogen oxides come from car exhaust, coal power plants, and factory emissions. The VOCs are released from gasoline, paints, and many cleaning solvents. When sunlight hits these chemicals, they form airborne particles and ground-level ozone, or smog. While ozone in the atmosphere is good in protecting us from the sun's harmful rays, it can be harmful to organisms at ground level. So how does this affect Grand Teton National Park? The park has generally good air quality, but is affected by air pollution from power plants, agricultural areas, industry, and oil and gas development. This can be harmful to the vegetation and animals that make the park so beautiful. Effects on plants. According to the National Park Service website, there are 17 species of plants in the park that are sensitive to ground-level ozone. The results of air pollution have negative effects on the quality of growth for plants. Ground-level ozone can cause visible leaf injury, growth and yield reductions, and altered sensitivity to stressors such as pests, diseases, and drought. This can be harmful to the park as many animals also rely on these plants. There are also many effects on animals. For example, fish. Acid rain falling in rivers and streams causes pH levels to rise, killing fish that are sensitive to pH fluctuations. Acidic rivers and streams can cause respiratory distress in fish. Acidic water is generally clear, causing a temperature and light increase in the water, resulting in the relocation of native fish that need a cooler and darker habitat in order to survive. This can be seen in Jackson Lake, which is the very large lake that runs through the park. Another example is birds. Birds are affected directly by coal power production exhaust, which can damage birds' respiratory systems. They also are affected by air pollution indirectly. Increase in wetlands pH causes fish kills, resulting in a decline in the osprey population as sources of food become scarce. Mercury accumulations as it moves through the food chain, becoming very harmful to predatory birds such as the bald eagle. Both of these birds can be seen in the park. Another effect on animals is insects. Insects are very susceptible to air pollution. Small fluctuations in air quality force certain insects to relocate, affecting other plants and animals connected to them. Insects that are more resilient to air pollution are those that digest organic waste less effectively, which can result in a buildup of organic waste when air pollution rises in an area. This affects other organisms such as plants being kept under control naturally, as well as the decomposition of dead organisms. Insects are the primary food for lizards, snakes, frogs, trout, and many birds including bluebirds, chickadees, woodpeckers, thrushes, wrens, sparrows, dippers, jays, sapsuckers, and a few ducks. Even bears depend on insects. They are very important to the park and are affected by the air pollution that harms them. Another effect is the visibility. The smog can play a role in visibility. The sky will have a haze, and this affects visitors of the park that are looking to take pictures of the beautiful scenery. Here below are two pictures that can be seen of the mountains. They would normally be very beautiful pictures, but are hazy because of the smog. Positives of smog. While smog itself may not be positive, it is the result of positive impacts in our world today. It occurs because mankind is making progress in factories, power plants, and other places. It can also be seen as good through the fact that part of smog is smoke. While there may be fires that destroy, those fires can also be seen as beneficial because it is an opportunity for new plant and habitat growth. Smog is a result of many changes in the world today. The technology that we have today is advancing. This affects the natural parks and how they are trying to be kept natural. Now, I will talk about the geology of Grand Teton National Park. Grand Teton National Park is a part of a fault block mountain system. This is formed by the shift of continental rifting. When they shift, one side is thrust upward to form mountains while the other pushes downward into the brittle upper crust. In Grand Teton, as well as many other places, a steep planar fault surface is formed known as escarpment. Here in this picture, there is a stretching between the east and west directions. The Teton Fault is just below the mountains in the pink. The hole is formed in the area where the two lakes are, seen in this picture. The mountains uplift one earthquake at a time along the 40-mile-long Teton Fault, the north-south trending crack in the Earth's crust. As the region stretches in an east-west direction, the stress builds to a breaking point where it generates an earthquake, lifting the mountain block skyward while dropping the valley floor. On average, the fault moves 10 feet in each earthquake, 6 to 8 feet up and 2 to 4 feet down. In the 10 million years since the fault began moving, the total offset is approaching almost 30,000 feet. As a quick estimate, the Flathead Sandstone on top of Mount Moron is 6,000 feet above the valley, and that same layer is buried roughly 24,000 feet below the valley floor on the east side of the fault. Here in this picture is another example of how this works. In Grand Teton, as well as many other places, a steep planar fault surface is formed known as escarpment. These often leave a lake in the valley below. Seen in this picture is Jenny Lake. This is the lake formed at the base of this formation. In this picture, you can see the steep drop-off of the Teton Mountains and the lake below. The hole represents the area closer to you in this picture. So what is the hole? Fur trappers of the 1800s referred to high valleys surrounded by mountains as holes. Jackson Hole, Wyoming, which lies partly in Grand Teton National Park, is a rift valley at the northeastern corner of the Basin and Range Province. The Teton Fault forms a prominent 7,000-foot escarpment, separating the uplifting block of the Teton Range from the downdropped valley. The valley has filled with a thick accumulation of sedimentary and volcanic strata, suggesting that old rocks beneath Jackson Hole have moved downward at least 30,000 feet along the Teton Fault. Like many other continental rifts, Jackson Hole has prominent lakes nestled against the active fault escarpment. Two of the prominent lakes are Jenny Lake and Jackson Lake. These lakes are both seen in the park. Teton Fault is still active and capable of generating a magnitude 7 to 7.5 earthquake.